Okay, we skipped over a few slides, but I just want to get right in. Excuse me while I adjust the screen. I want to get right into stream erosion and how that process works. Now, there's videos, or I should say animations, in the module, the weekly module, so make sure you watch those because they're very informative and will help you understand what's going on. So stream erosion happens in a couple ways. One is through hydraulic action, where you squeeze together and then release water that loosens and lifts the rocks. There's abrasion where the rocks, grind up against the sides and the bottom of the stream bed, kind of like sandpaper, and will erode it. And the more turbulent the flow, the more water particles will move. And these are some examples. So notice how turbulent this is. So you're getting a lot of movement between particles. They will abrade the sides here, and we're not seeing the bottom, of course, but it would also erode the bottom of the stream. And remember, all this is related to the width and the depth and the velocity of the discharge of the stream flow. And so, when you multiply those together, you get a cubic feet or cubic meters per second, and that gives you some idea of the erosional qualities of a river or stream. A little calmer here. Now that doesn't mean there's no erosion happening. As long as the water is flowing, there's still some erosion going on, either on the sides or on the bottom. When it reaches its base level, that means that the streams will not erode anymore. They just don't have the power to do so. And again, the Nile River is a really good example of that when it has reached its level in Egypt. Now, the other important thing that streams do is they transport sediment. Remember earlier we looked at both the Mississippi and the Amazon, and you could see, by the fact that they're what we perceive to be muddy, that's sediment within the water, and it's being transported. The competence of the stream is its ability to move particles of a specific size. And again, it's a function of the velocity and available energy. And then the capacity is the total possible sediment load that a stream can transport. And again, there's animations in the weekly modules, so make sure you watch those. Now, transport can happen in four ways. Solution, where it's a dissolved load. A suspension where it's fine grained and floats, in the stream water. Traction where it drags across the stream bed. And what we call saltation, where the particles bounce up and down along the bottom because they're basically too heavy to be picked up and slide. So again, this is in your, there's an animation for this in your weekly modules. Make sure you watch this.